When I was coming out of high school, I really wanted to be a doctor. I wanted to treat patients directly. What really made the change was when I joined Dr. Georgiou's protein engineering lab. I entered not knowing much at all about protein engineering, but I just saw graduate students, postdocs, just working together to engineer actual therapeutic proteins.
So this is a very collaborative lab. There's usually postdocs and graduate students collaborating on high-profile projects together, and Dr. Georgiou recruits really diverse people.
In our research group, we have engineers and immunologists and microbiologists and chemists all working together and all benefiting from each other's expertise, and that has been a key ingredient in creating the magic, if you will.
The lab has a personality to try just about anything, and that's why I love it here.
It wasn't at all about the following of protocols, but instead about scientific innovation and creativity. And it was a way that I could actually apply what I learned to solve real-world problems.
We end up doing a lot of basic science here, but why not do basic science in something that might have a real-world application, like an antibody to anthrax, or an enzyme that cures a cancer, or a diagnostic tool, or a strain of bacteria that makes production of some other therapeutic possible. We have an eye towards what is it good for? What's the product? What's the purpose?
Proteins control almost every biological function that you can think of. The fact that we have the technology now to manipulate them really opens the doors to so many possibilities.
Currently, engineered protein drugs represent the fastest growing class of therapeutics in the pharmaceutical industry.
Think about cancer treatment. The gold standard today for cancer treatment is chemotherapy, and while it saves many lives, it is actually quite a blunt approach.
Engineered protein therapeutics have a very precise function, as opposed to chemotherapeutic agents which have multiple targets in the body, and therefore they typically give rise to very serious side effects. The vast majority of therapeutics are being initially discovered at universities. Industry is very good at developing products, but the initial discovery, the innovation, has to come from an environment where you have a very interdisciplinary group of scientists working together and coming up with new ideas. These ideas can be nurtured, and these ideas can be realized because of the freedom of the academic environment. Universities are great engines of innovation.